So here we are with just a little bit of Unit 1 Matter and Measurement test review. We're looking here at the review sheet and hopefully we can answer questions you might have. Okay, we're looking at significant figures here. Let's see if I can highlight the significant figures and tell you why some of them are not significant. The reason this only has two significant digits is the rule about zeros. These zeros cannot be significant digits because they have to be both at the end of the number and after the decimal point. Here, in scientific notation, all significant digits are written. Sometimes students make the mistake of thinking that these digits might be significant. That is not the case. Now remember, significant digits is not about the importance of the digit. It's about how precise the instrument was that made the measurement. These zeros right here are still important. They're just not significant digits. Okay, enough said about that. Here we have, of course, the non-zero digits are significant, and this zero right at the end is a significant digit because it is at the end of the number and it is to the right of the decimal place. All four of these are significant because these last digits lie at the end of the number and after the decimal, making these significant because they lie between significant digits. All five of these are sig figs. Here, only these two are sig figs. Any questions? Refer to the video on significant digits from Khan Academy that is on the website. Also, if you have any questions about addition, refer to that, but just keep in mind that this is the main rule. The answer cannot be more precise than the device you're making the measurement with. If this device is only precise to the closest 1,000 meters, that means we're looking at a Google Earth picture from way out in space somewhere, then adding a few meters to that is not going to make a significant difference. We're not going to notice it. It's like a drop in a pond of water. Not going to be noticeable. So here, this is the correct answer. In question number 2, part C, these meters cubed cancel these 3 meters. Meters times meters times meters. And the new unit is centimeters cubed because there are 3 centimeters. Centimeters times centimeters times centimeters makes centimeters cubed. 100 times 100 times 100 is a million. So we end up having an answer with 5 significant digits. And that should be the answer. We moved the decimal point 6 places. Question 3, these refer to SI units and typically used units in the SI system. When we're using the electronic balance in class to measure mass, you wrote it down as the gram, even though you know the base unit for mass is the kilogram. When a thermometer measures temperature, it says degrees Celsius on it, even though the base unit for temperature is Kelvin, and we'll certainly use the Kelvin temperature scale, and you'll come to understand why it is important. When measuring time, the base unit is seconds, but you might need to be able to convert that to things like minutes, hours, days, years, things like that. Well, of course, one of my favorite places to travel is Vancouver, British Columbia, or other places to the north. And when I get there, I have to kind of convert my speed limit to kilometers per hour. We usually use kilometers to measure long distances, but the base unit of length is the meter. Now, some conversion factors you want to keep in mind are that 1 kilometer is 1,000 or 10 to the third meter. 1 meter is the same as 100 centimeters or 1 times 10 to the 2. 1 second is the same as 1,000 milliseconds, in the same way that 1 kilometer is 1,000 meters. And a mole is, oh, I think this is the wrong number right here. I think that needs to be 10 to the 6 micrometers. 1 million micrometers. So the next few problems here deal with the skill of dimensional analysis, or the factor label method. Now, of course, in our chemistry classes here at Oak Harbor High School, we use a 5-point grading system, and so to get all 5 of those points, you need to be sure that your units show all the way through the problem, that when you cancel your units because they're the same in the numerator and denominator, that you show those units being canceled, and the unit that is left is the unit that you were searching for, and that's what ends up in your answer. That's the U in the UDRSS. The data is to identify clearly in the problem what it is you're starting with and what it is you want to know about. And then, of course, the R is the relationship. In this kind of problem, we're giving that relationship point for getting these relationship units in the correct place so you can cancel them out from the beginning of the problem to the end. We're putting the substitution in when you put in the correct number to go with each of those units. And then the solution in this case is 750 centimeters. That's what make up the points. Now, as far as how you get to the answer for these problems, what you want to be sure you're considering is once you've identified what you know and what you don't know, make a plan to get from what you know to what you need to know. Make that plan. In this case, I knew I started with 15 cubic centimeters of gold, and I look up here and I see a relationship, a conversion factor, that 1 centimeter cubed of gold is, silver. 1 cubic centimeter of silver is 10.5 grams of silver. So I'm going to start with that, but I'm going to use that conversion factor in such a way that the units, centimeters of silver, cancel with centimeters of silver, and grams is the new unit I show up with on top here, grams of silver. Now let me erase that circle to make sure you can see the correct units. So that is the unit my answer should come out in. Now here I've rounded my answer to 3 significant digits. We're going to take a little station identification break here.